Unmanned warfare: how 75% of military operations could be automated by 2030. Overview. The evolution of unmanned warfare is rapidly gaining traction, with projections suggesting that up to 75% of military operations could be automated by the year 2030. This shift is heavily influenced by advancements in drone technology, artificial intelligence (AI), and automation, which are reshaping the landscape of modern warfare. As military organizations increasingly adopt autonomous systems, the implications for strategy, safety, and operational efficiency are profound. Key insights. 1. Technological advancements in drones. The military drone market is poised for substantial growth, with a projected compound annual growth rate (CAGR) of 13.8% from 2024 to 2030. Innovations in materials science, battery technology, and miniaturization are enhancing drone capabilities, allowing for longer flight times, greater payload capacities, and improved stealth features. The development of autonomous and semi-autonomous drones is gaining momentum, enabling these systems to carry out complex missions with minimal human intervention. This capability not only mitigates risk to personnel but also enhances mission success rates through the application of sophisticated navigation and target recognition algorithms. 2. Integration of autonomous systems. Military drones are being integrated into broader defense systems, fostering a network-centric warfare approach. This integration facilitates seamless data sharing and coordinated operations across various military assets, including ground-based radar systems, manned aircraft, and naval vessels. The concept of network-centric warfare is critical for modern military strategies, underpinning the interconnectedness of military operations. 3. Focus on tactical drones. Smaller tactical drones are increasingly utilized for short-range missions, particularly in intelligence, surveillance, and reconnaissance (ISR) operations. Their portability and rapid deployment capabilities make them particularly effective in urban and counterinsurgency warfare, where quick responses are essential. 4. Counter-drone technologies. The proliferation of military drones has led to a corresponding rise in counter-drone technologies. These systems aim to detect and neutralize hostile drones through methods such as radar detection and RF jamming. This development reflects the growing need to address asymmetric warfare tactics, where non-state actors use commercial drones for attacks. Comparative highlights from reports. Source 1: Globe Newswire emphasizes the commercial and military viability of autonomous drones, focusing on technological innovations and market growth potential. It highlights the increasing adoption of autonomous systems and the shift towards smaller tactical drones designed for rapid deployment and versatility in various combat environments. Source 2: Market.us provides statistical insights into the integration of artificial intelligence in military operations, underscoring the strategic significance of automating various military functions. The report discusses the broader implications of AI in enhancing operational efficiency and decision-making processes within military strategies. Common themes. Both sources agree on the growing reliance on drones and automation in military operations. They highlight technological advancements and market trends that are driving this transformation, with a shared emphasis on the benefits of enhanced safety and efficiency resulting from reduced human intervention in military operations. Timeline of developments. 2024 to 2030, the military drone market is expected to grow significantly, driven by advancements in drone technologies and AI. Companies like Xenotech and Ag Eagle Aerial Systems are actively working on developing and deploying innovative drone technologies for military applications. Ongoing innovations: organizations are testing and refining various applications of drones for ISR, logistics, and other military functions. The development of drone command centers and swarm technologies is at the forefront of these innovations. Future projections. By 2030, it is anticipated that up to 75% of military operations may be automated, fundamentally altering the nature of warfare and military strategy. Key developments in the drone market. Xenotech Incorporated. Xenotech is establishing a beyond visual line of sight BVLOS drone testing facility in Turkey to advance its Xenodrone 1000 models for U.S. defense and NATO applications. This facility will focus on testing applications such as ISR and logistics, enhancing the capabilities of military drones in real-world scenarios. AgEagle Aerial Systems. Recognized for its unmanned aerial systems, AgEagle recently secured a significant order for multispectral sensors, underscoring the growing demand for advanced drone technologies in military and commercial sectors. Red Cat Holdings, in partnership with Palantir Technologies. Red Cat is integrating advanced AI software into its Black Widow drones, enhancing their navigation capabilities and operational effectiveness in military operations. Ondas Holdings. Ondas announced a new order for its aerobotics subsidiary focusing on aerial security and data services using autonomous drone infrastructure, further emphasizing the shift towards automated solutions in defense. Dragonfly Incorporated. Dragonfly is exploring drone delivery projects aimed at improving medical supply logistics, demonstrating the versatility of drones beyond traditional military applications. Conclusion. The integration of unmanned systems in military operations is set to redefine traditional warfare paradigms. The convergence of technological innovation with military needs signals a significant transition towards automation in defense operations. As advancements in AI and drone technologies continue to evolve, the implications for strategy, safety, and operational efficiency will be profound, potentially transforming the nature of warfare by 2030. The military's increasing reliance on autonomous systems highlights a future where human involvement in combat operations is minimized, fundamentally altering the dynamics of modern warfare. Unmanned warfare is ushering in a transformative period for military operations, with projections suggesting that up to 75% of these operations could be automated by 2030. This shift is primarily driven by advancements in drone technology, artificial intelligence, and network-centric warfare models. However, several counterintuitive insights emerge from this discussion that challenge conventional perceptions of warfare and military engagement. Counterintuitive insights. 1. Increased risk of escalation. One might assume that the use of unmanned systems would lead to less aggressive military engagement due to reduced personnel risk. However, the opposite could be true, as nations leverage autonomous drones for surveillance and strikes. The threshold for initiating conflict may lower. Military leaders may be more inclined to engage in hostile actions when human lives are not directly at stake, potentially leading to increased military confrontations and rapid escalation of conflicts. 2. Complexity of human-AI interaction. While automation aims to reduce human intervention, the reality is that the integration of AI in military operations will require significant human oversight and decision-making. The complexity of ethical considerations surrounding autonomous warfare means that military leaders must grapple with critical decisions that AI systems may not be equipped to handle. This counterintuitive need for human judgment amidst increasing automation may paradoxically increase the cognitive load on military personnel rather than alleviate it. 3. Vulnerability to cyberattacks. The reliance on automated systems and interconnected drone networks could create new vulnerabilities. While drones may enhance operational efficiency, they also present targets for cyberattacks that could cripple military capabilities. The expectation that automation will enhance security could be misleading, as adversaries may seek to exploit these vulnerabilities, leading to a potential arms race in cyber defense technologies. 4. Economic displacement. The anticipated growth of automated military operations may lead to significant job displacement within the defense sector. While automation is often viewed as a means to enhance efficiency and reduce costs, the societal implications of widespread job losses among military personnel and defense contractors could provoke public backlash and resistance against further automation initiatives. This economic disruption can create instability that undermines the very security that automation aims to enhance. 5. Rise of asymmetric warfare. The proliferation of autonomous drones may not only empower state actors but also non-state actors such as insurgent groups and terrorist organizations. The accessibility of drone technology can democratize warfare, enabling smaller factions to conduct sophisticated operations that can challenge larger military powers. This dynamic could lead to an increase in asymmetric warfare tactics where conventional military forces face unconventional challenges complicating traditional military strategies. 6. Counter-drone technology arms race. While the focus is on advancing drone technology, there is an equally pressing need for counter-drone systems. As military drones become more prevalent, adversaries will develop countermeasures to neutralize these threats, leading to an arms race in drone and counter-drone technologies. This ongoing competition may divert resources and attention away from other critical military capabilities, potentially leaving gaps in overall defense strategies. 7. Ethical dilemmas and accountability. The shift toward unmanned warfare raises profound ethical questions regarding accountability for actions taken by autonomous systems. If an AI-driven drone engages in an unlawful act, determining responsibility becomes complex. This ambiguity challenges traditional notions of military accountability and justice, complicating legal frameworks governing warfare. 8. Urban warfare challenges. While tactical drones are designed for urban and counterinsurgency operations, their use in densely populated areas poses significant risks to civilian populations. The assumption that automation can minimize civilian casualties may not hold true if drones misidentify targets or malfunction. The complexities of urban warfare could lead to increased civilian casualties, undermining the moral high ground often claimed by military forces. Conclusion. The discourse surrounding unmanned warfare and automation in military operations highlights a range of technological advancements that promise to reshape the battlefield. However, as we consider the implications of these changes, it is crucial to recognize the counterintuitive insights that challenge our understanding of warfare, military ethics, and the socio-economic landscape of defense. The future of military operations will not only be defined by technological capabilities but also by the complex interplay of human judgment, ethical considerations, and the evolving nature of conflict itself. As nations pursue automation in warfare, they must navigate these challenges thoughtfully to ensure that advancements in technology do not compromise the principles of justice, accountability, and human security that underpin military engagement. Unmanned warfare, insights and overlooked content. The report on unmanned warfare and the potential automation of 75% of military operations by 2030 is a pivotal discussion point in military strategy and technology. While the report summarizes key insights, several crucial elements are likely to be overlooked by many readers, yet they hold significant implications for the future of warfare, defense policy, and international relations. 1. Ethical and legal considerations. One of the most significant but often ignored aspects of the rise of unmanned warfare involves the ethical and legal ramifications of using autonomous drones. As military operations increasingly rely on autonomous systems for decision-making and targeting, questions arise about accountability and the potential for violations of international humanitarian law. The use of drones in combat scenarios raises concerns about the principles of distinction and proportionality in warfare. Significance. The ethical implications of unmanned warfare are profound as they challenge the existing frameworks governing armed conflict. The automation of lethal force could lead to decisions made without human oversight, increasing the risk of unintended civilian casualties and escalation of conflicts. This necessitates urgent discussions among policymakers, legal experts, and military leaders about the rules of engagement in an age of automated warfare. 2. Cybersecurity risks. While the report discusses advancements in drone technology and integrated systems, it often underestimates the cybersecurity risks associated with autonomous military operations. As drones become more interconnected and reliant on data-sharing networks, they also become more vulnerable to cyberattacks. The potential for enemy forces to hack into drone systems to take control, disrupt operations or gather intelligence is a critical concern. Significance: the reliance on advanced technology increases the attack surface for adversaries. A successful cyber attack on military drones could compromise missions, lead to critical failures, or expose sensitive data. This highlights the need for robust cybersecurity measures and the development of counter-cyber strategies as integral components of military planning. 3. Impact on military personnel and workforce. The shift towards automation raises questions about the future roles of military personnel. As drones and other unmanned systems take over more operational tasks, the nature of military jobs will inevitably change. There is a risk of job displacement for certain roles, but it also opens opportunities for new positions focused on drone operation maintenance. And cybersecurity. Significance: understanding the impact on military personnel is crucial for effective workforce planning and training. The military must invest in reskilling programs to prepare personnel for a future where human roles may shift from direct combat to managing and overseeing automated systems, ensuring that the workforce remains adaptable and skilled. 4. Asymmetric warfare and new threats. The proliferation of autonomous drones can potentially democratize military capabilities, allowing non-state actors and smaller nations to access advanced technology. As these entities adopt drone technology for asymmetric warfare, traditional military powers might face new challenges that disrupt conventional strategic advantages. Significance: the rise of drone usage among non-state actors could lead to an increase in irregular warfare tactics, necessitating a re-evaluation of military strategies and responses. Policymakers must consider how to counter these emerging threats while balancing the ethical implications of responding to asymmetric warfare with advanced technology. 5. Environmental and collateral damage. As military operations increase their reliance on drones, the environmental impacts of such activities are often overlooked. The use of drones for surveillance, combat, and logistics could lead to environmental degradation, particularly in conflict zones where drone operations may disrupt local ecosystems or contribute to pollution. Significance: the environmental implications of unmanned warfare must be addressed to ensure sustainable military practices. This consideration aligns with global efforts to mitigate climate change and protect biodiversity, reinforcing the idea that military operations should also take into account their environmental footprint. 6. Strategic shifts in military alliances. The integration of unmanned systems into military operations is likely to influence global military alliances. Countries that invest heavily in drone technology may establish new defense partnerships or redefine existing ones based on shared technological capabilities and operational approaches. Significance: the strategic landscape of international relations is evolving with the advent of unmanned warfare. Nations that lead in drone technology may gain leverage in diplomatic negotiations and military alliances, affecting global power dynamics. Understanding these shifts is essential for policymakers to navigate the future of international security effectively. 7. Public perception and political implications. The increasing use of drones in military operations could also impact public perception of warfare. As drone strikes become more prevalent, there may be growing concerns about transparency, civilian casualties, and the ethical implications of remote warfare. Public opinion can significantly influence political decisions regarding military engagement. Significance: the political ramifications of unmanned warfare are profound, as they could shape legislation, military funding, and public support for military operations. Military leaders and policymakers must engage with the public to address concerns and foster understanding of the strategic necessity and ethical considerations of drone warfare. Conclusion: the report on unmanned warfare and the potential automation of military operations presents a transformative vision of future conflict. However, significant aspects, including ethical considerations, cybersecurity risks, workforce implications, asymmetric warfare challenges, environmental impacts, strategic shifts in alliances, and public perception, are crucial for a comprehensive understanding of this evolution. Addressing these overlooked elements will be essential for shaping a responsible and effective approach to the integration of unmanned systems in military operations. Ensuring that technological advancements do not outpace ethical and strategic considerations. In-depth analysis and discussion points on unmanned warfare and automation of military operations by 2030. 1. Technological advancements in drone capabilities. The military drone market is on a trajectory of exponential growth, projected to grow at a compound annual growth rate (CAGR) of 13.8% from 2024 to 2030. This growth is attributed to significant technological advancements that improve drone capabilities, including endurance, payload capacity, and stealth features. Innovations in materials science, battery technology, and miniaturization are transforming drones into more efficient and versatile tools for military operations. The implications of these advancements are profound, as they enable military forces to conduct a wider array of missions with increased operational effectiveness while minimizing human risk. 2. Shift towards autonomous and semi-autonomous systems. A notable trend in military operations is the shift towards autonomous and semi-autonomous drones that can execute complex missions with minimal human intervention. This trend not only reduces personnel risk but also enhances mission success rates. The development of sophisticated algorithms for navigation, target recognition, and obstacle avoidance is critical in enabling these autonomous operations. As military organizations increasingly rely on these capabilities, a discussion on the ethical considerations and potential operational risks of fully autonomous warfare becomes essential. 3. Integration of military drones into network-centric warfare. The integration of military drones into broader defense systems is facilitating a network-centric warfare approach. This integration allows for seamless data sharing and coordinated operations among various military assets, including ground-based radar systems, manned aircraft, and naval vessels. The resulting interconnected battlefield environment enhances situational awareness and operational responsiveness. Analyzing this shift reveals the strategic advantages of such integration as well as potential vulnerabilities such as susceptibility to cyberattacks or system failures. 4. Emergence of counter-drone technologies. As military drones become more prevalent, the need for counter-drone technologies is intensifying. These systems aim to detect and neutralize hostile drones through various methods, including radar detection, RF jamming, and kinetic interception. The rise of asymmetric warfare tactics, where non-state actors utilize commercial drones for attacks, is accelerating the development of these countermeasures. Engaging in a discussion on the implications of counter-drone technologies raises questions about the balance of power in modern warfare, the potential for an arms race in drone technology, and the ethical considerations surrounding the deployment of such systems in conflict zones. Conclusion. The landscape of military operations is undergoing a significant transformation due to the rapid advancements in unmanned warfare technologies. As we approach 2030, the potential for automating up to 75% of military operations presents both opportunities and challenges. Engaging in a thorough analysis of these key points will facilitate a deeper understanding of the future of warfare, the ethical implications of automating combat, and the strategic considerations for military organizations adapting to a new era of unmanned systems. Famous historical cases of unmanned warfare. 1. The use of drones in the War on Terror 2001-present. Since the onset of the War on Terror post 9/11, the United States has increasingly relied on unmanned aerial vehicles, UAVs, commonly known as drones, for military operations. One notable instance is the use of Predator drones in Afghanistan and later in Pakistan, Yemen, and Somalia. These UAVs have been utilized for targeted strikes against suspected terrorist leaders and operatives while minimizing the risk to personnel. The drone strikes illustrate a shift towards remote warfare where operators conduct missions from thousands of miles away, reducing the footprint of U.S. military personnel in conflict zones. This case has raised ethical questions regarding sovereignty, civilian casualties, and the implications of autonomous warfare. 2. Operation Desert Storm 1991. During the Gulf War, the use of unmanned systems took a significant leap with the deployment of the RQ-2 Pioneer UAV, which was utilized by the U.S. Navy for reconnaissance missions. The Pioneer provided real-time intelligence and battlefield surveillance, marking one of the first instances where unmanned systems played a critical role in a major military operation. The success of the Pioneer set the stage for future developments in drone technology and paved the way for the extensive use of UAVs in subsequent conflicts. This operation exemplified how unmanned systems could enhance situational awareness and operational effectiveness in modern warfare. 3. The V-1 Flying Bomb. World War II. The V-1 flying bomb, developed by Nazi Germany, was one of the first instances of an unmanned weapon system used in warfare. Deployed against London and other Allied targets, the V-1 was essentially a cruise missile that could be launched from a ground-based site. Although not fully autonomous by today's standards, the V-1 represented a significant step towards unmanned warfare, showcasing the potential for machines to carry out attacks without direct human control. The V-1's introduction marked the beginning of a new era in military technology, influencing future missile development and the evolution of unmanned aerial systems. These historical cases illustrate the evolution of unmanned warfare, highlighting technological advancements and the shifting nature of military operations that continue to influence contemporary strategies and ethical considerations in modern conflicts. Future outlook: unmanned warfare and automation in military operations by 2030. As we look ahead to 2030, the landscape of military operations is set to undergo a significant transformation, with the anticipated automation of up to 75% of these operations. This shift will primarily be driven by advancements in unmanned systems, particularly drones and artificial intelligence (AI). Below are key predictions and trends shaping the future of unmanned warfare. 1. Widespread adoption of autonomous systems. The military drone market is projected to achieve a compound annual growth rate (CAGR) of 13.8% from 2024 to 2030. This growth will be fueled by the increasing capabilities of autonomous and semi-autonomous drones, which can perform complex missions with minimal human intervention. By 2030, we expect a majority of military operations, particularly in intelligence, surveillance, and reconnaissance (ISR), to be executed by autonomous drones, reducing the risk to personnel and improving operational efficiency. 2. Integration of AI and advanced algorithms. The integration of AI into military operations will be pivotal. Advanced algorithms for navigation, target recognition, and decision-making will enable drones to operate independently in dynamic environments. This AI-driven capability will enhance mission success rates and allow for real-time adjustments during operations. As such, we foresee AI becoming a cornerstone of military strategy, enabling forces to respond more effectively to threats and challenges. 3. Network-centric warfare. The future of military operations will increasingly adopt a network-centric approach, where drones and other military assets are interconnected through advanced communication systems. This integration will enable seamless data sharing and coordination between ground, air, and naval forces, creating a more cohesive operational environment. By 2030, we anticipate that military operations will rely heavily on real-time data analytics, allowing for informed decision-making on the battlefield. 4. Emergence of tactical drones. Smaller tactical drones designed for short-range missions will become more prominent in military operations, particularly in urban warfare and counterinsurgency scenarios. These drones will be valued for their portability, rapid deployment capabilities, and effectiveness in ISR operations. By 2030, we expect tactical drones to play a critical role in ground operations, providing troops with real-time situational awareness. 5. Counter-drone technologies. As the use of military drones proliferates, so too will the need for counter-drone technologies to detect and neutralize hostile drones. Innovations in radar systems, radio frequency RF jamming, and kinetic interception solutions will be critical in protecting military assets and infrastructure from drone threats. By 2030, we predict that counter-drone technologies will be integrated into military strategies as a standard defense measure against asymmetric warfare tactics employed by non-state actors. 6. Human-machine collaboration. While automation will dominate military operations, the role of human operators will evolve rather than diminish. Future military strategies will emphasize human-machine collaboration, where operators oversee drone fleets and make strategic decisions based on data provided by autonomous systems. This hybrid approach will ensure that while drones handle routine tasks, human judgment remains integral in complex decision-making scenarios. 7. Ethical and legal implications. The rise of unmanned warfare will inevitably raise ethical and legal questions regarding the use of autonomous systems in combat. By 2030, military leaders and policymakers will need to address issues related to accountability, the rules of engagement, and the potential for unintended consequences of autonomous operations. Developing a robust legal framework governing the use of drones in warfare will be crucial to ensuring compliance with international humanitarian law. 8. Global military dynamics. The shift towards automated military operations will have significant geopolitical implications. Nations that invest heavily in drone technology and AI will likely gain strategic advantages on the global stage. By 2030, we anticipate that military powers will increasingly engage in an arms race focused on drone technology, leading to new alliances and tensions in international relations. 9. Logistics and support operations. Beyond combat roles, drones will revolutionize logistics and support operations within military frameworks. Autonomous drones will facilitate the transportation of supplies, medical equipment, and critical cargo, enhancing operational readiness and efficiency. By 2030, we expect that logistical operations will be largely automated, allowing for rapid response capabilities in various operational theaters. Conclusion. The future of unmanned warfare is poised for rapid transformation, driven by advancements in drone technology and artificial intelligence. By 2030, the military landscape will be characterized by a high degree of automation, network-centric operations, and enhanced collaboration between humans and machines. As militaries around the world adapt to these changes, they will also face new ethical, legal, and geopolitical challenges that will shape the future of warfare. The convergence of technology and military strategy will redefine how conflicts are fought and managed in the coming decade.